This is a video on linear inequalities. Now, an inequality is similar to an equation, except an equation will contain an equal sign, and an inequality will contain one of these four signs instead. So it's less than or equal to, greater than or equal to, or greater than. Okay, it's called an inequality if it contains one of these. Now, a linear inequality is one where there's no non-linear operations in there. So there's no squaring, there's no square roots, there's no cubing, there's no logs, there's no exponentiation. There's nothing like that. It's just very straightforward, multiple times variable, as you would in a linear equation. So a typical linear inequality might look like something like ax plus b, and then one of these four symbols, let's just go with less than, cx plus d. There may be some brackets kicking around or something else in there which you need to be aware of, but these are the kind of things that we're going to be looking at. And what we're aiming to do is we're trying to get to a solution where x is less than some number, or perhaps x is greater than some number. And we need to get to what that number is. An equation will give a number as an answer, whereas an inequality will give a range of numbers as answers. So there's several numbers which tend to satisfy inequalities. Before we get on with onto some examples, I do want to just address some set notation. So sometimes a question in A-level will ask you specifically to leave your answer in set notation, which means you must leave your answer in set notation. You must use this notation. So what I'm going to do is in the examples, I'll give the answers in set notation as well as just an inequality. So set brackets. Inside the brackets is your set, your definition. You can combine set brackets together to make a bigger set or a smaller set by using unions and intersections. Essentially, this is the words or and. So either one of the two brackets has to be true, or both of the brackets have to be true. And then also we have a colon, which in maths means such that. Okay, so you'll see me using these throughout the video. Okay, so examples. Question number 1. Nice simple one. 2x plus 5 is less than or equal to 13. So we can treat inequalities like this exactly as we would equations, except we cannot multiply or divide by a negative number. Okay, we cannot multiply or divide by a negative number. We can multiply or divide by positive numbers, that's fine. We can add and subtract as much as we want, that's fine. But we cannot multiply or divide by negative numbers. And when we do quadratics, we also can't divide by variables quite as easily, because something happens when that happens. So yeah, we don't, or try not to multiply and divide by negative numbers. Just a little illustration why. Hopefully you'll agree with me that 4 is less than 5. Now if I times that by -1, then -4 is less than -5. Well, that is not true. This is true. So you can't, that's just a numerical example there, showing that you can't just times by -1. And in fact, if you do, you could just flip the direction of the inequality, and that would work. But I'd rather try and stay away from timesing and dividing by negatives. So let's solve this as we would a normal equation. So 2x is going to be less than or equal to 8. That's subtracting 5 from both sides. Divide by 2. X is therefore less than or equal to 4. And that's the answer. Okay, it's as simple as that. In set notation, it would be x such that x is less than or equal to 4. Okay, and that's it. There's no unions or intersections because it is just a one inequality. Another way to visualize the solution would be to use a number line. So let's go from 0, 1, 2, 3, 4, 5, 6, and so on. We want all the values of x such that they are less than or equal to 4. So what I'm going to do is I'm going to put a filled-in circle here, and a filled-in circle indicates that we want to include the number. So we're going to include the number 4 because it's less than or equal to. And the direction we want is less than. So the arrow goes off that way. And this is a number line representation of the answer. Okay, question number 2. Just a little bit more algebra to work with, but the principle is exactly the same. So let's multiply out the brackets first. And then what I'm going to do is just combine all the x's onto the left and all the constants onto the right. So I'm going to add 2x to make a 5x. 5 plus 16 is 21. Add the 15 makes 36. Okay, I've not times or divided by anything. I've just added and subtracted there, so the inequality is fine. And then divide by 5, I'll get x is greater than 7.2. Okay, so in set notation, I would leave the answer as x such that x is greater than 7.2. And on a number line, let's do 5, 6, 7, 8, 9, 10. And this time I don't want to include 7.2, so what I do to represent that is I would have a hollow circle. Okay, it's a circle that's not filled in, called a hollow circle. It means you don't include the limit, the end of the line, and all the numbers that way. So all of the numbers this side of 7.2 satisfy this inequality. Okay, that's the solutions there. Okay, some harder ones then. Find the set of values of x which satisfy this or this. So this is where we start to come into having two inequalities at play. Let's just solve each one separately, and then let's have a look at the number line to see what that looks like. So it's going to be 5x plus 2 is less than 3x minus 18. Subtract 3x from both sides, that's going to be 2x. And subtract 2 from both sides is less than minus 20. And then divide by 2. X is less than minus 10. This one we're going to have 2x minus 9 is less than 3x minus 12. Subtract 3x from both sides, it's going to be minus x. Add 9, that's going to be minus 3. Now at this stage, if it were an equation, I would times both sides by minus 1. But I can't do that because it's an inequality. So you could do that and change the direction. But what I'm actually going to do is I'm going to instead add x plus 3 to both sides of my inequality. And that's going to give me then a 3 on the left and an x on the right. So I've now got 3 is less than x, or equivalently, x is less than 3. Sorry, x is greater than 3. Okay, so I've now got these two, and they're separated by the word or, which means either one of these branches will satisfy the inequalities. The set of values of x. So I need to go down as far as minus 10 and up as far as 3. So minus 10, I'm actually going to go in 2s, minus 6, minus 4, minus 2, 0, 2, 4, 6. Let's pop a minus 12 on there as well. Okay, so x is less than minus 10. So that's going to be a hollow circle because we're not including minus 10. And we want less than, so that's going to be to the left. And here we want x is greater than 3. Don't include 3, so we want a hollow circle at 3. And we want it to the right because it's greater than. And now we can see the solutions then are all the real numbers except for any numbers between minus 10 and 3. So any number down here or any number up there will satisfy one of those inequalities. And because it's separated by the word or, it only needs to be one. So as a set notation, we would write the answer as x such that x is less than minus 10, or, which is that union symbol, x such that x is greater than 3. And that's the solution. If you're going to write it as inequalities, you would have to write it as x is less than minus 10, physically use the word or, and then x is greater than 3. Okay, but this is better than using the word or because it's got a piece of mathematical notation in there instead. Okay. And my final example, we're going to separate them with the word and. Again, treat them separately. So we're going to have 15. I'm going to add 8x this time. So 15 plus 3 is going to be greater than 10x plus 8x. So that's going to be 18 is greater than or equal to 18x. And then divide both sides by 18. And that's okay because 18 is positive. So I get x is less than or equal to 1 on the left. This one is going to be a 5x plus 7 is greater than 2x minus 20. Subtract the 2x to make a 3x. subtract the 7 to make a minus 27, and I'm going to get x is greater than minus 9. So I've got x is less than or equal to 1, and x is greater than minus 9. So let's have a look at the number line. Let's go down as far as minus 9. So again, I'm going to go in 2s for minus 10 this time. So minus 4, minus 2, there's my 0, there's a 2, there's a 4. The top inequality says that x is less than or equal to 1, so I'm going to include the 1, so it's going to be a solid circle, and it's going to go to the left. So that's this inequality. This one, x is strictly greater than minus 9, so it's going to be a hollow circle there. Okay, hollow because it's not including the minus 9, and that's going to be to the right. And we want them both to be true because it's the word and, so they both must be true. So over here at minus 10, only 1 is true, so that doesn't satisfy the original question. And over here 2 is true on the bottom one, but not the top one, so therefore that doesn't satisfy. But anything in between minus 9 and 1, including 1, does satisfy both. So the solution is this line here. Okay, so that's the solution line, and how we would write that is you would say x such that x is less than or equal to 1, and x such that x is greater than minus 9. Or, if you weren't asked to leave it in set notation, you could leave it as minus 9 is less than x is less than or equal to 1. And that is the answer. Okay. Next video will be on quadratic inequalities. Thank you for watching.